our series where we make organic chemistry so simple and comprehensive. If you are coming across my channel for the first time, my name is Basi Ejoba. I'm a 400 level student in the University of Calabar studying medical laboratory science, and in my channel I help students develop their academic game. I also share helpful tips on this channel focusing on personal development. So if you love content like this, don't forget to hit on the red subscribe button so I can continue getting updates anytime I drop videos like this, and so that you can help me grow. And just like I've said that this series is focused on making organic chemistry so simple to students, today we'll be talking about the important aspect on why molecules have the shape they do. Why is it that water have a bent shape? Why is it that diamond have a tetrahedral shape? That is what we are going to discuss today. And this concept falls on what is known as hybridization. So today we are going to talk about the meaning of hybridization, the types of hybridization, and the bonding in organic compound. If you are watching this video from as a student in the University of Calabar, please drop it in the comment section so that I will know. If you are watching this video from outside the country, because I was surprised that my video was particularly watched by people from South Africa, so please drop it in the comment section so that I will also know. So let's talk about the meaning of hybridization. What is hybridization and how come molecules have the shape they do? Hybridization is simply the mixing or the blending of atomic orbitals. Permit me to write. I say it's the word hybridization is simply the mixing and blending, simply the mixing and blending of atomic orbitals in order to get a new set of orbitals. Now this new set of orbitals that undergoes what? Blending, where two orbitals or two atomic orbitals blend or mix together to give a new set of orbitals. These new set of orbitals are known as the hybrid orbitals. They are known as the hybrid. I don't know why my marker is not writing well. They are known as the hybrid orbitals. The hybrid orbitals. So, hybridization is simply the mixing and the blending of atomic orbitals in order to get a new set of orbitals. And this new set of orbitals is known as the word hybrid orbitals. Now, in standard word organic word chemistry, there are two words. Let me check here. They say what? There are two electrons in the 2s orbital. There are two electrons in the 2s orbital. In the 2s orbital, there are normally two electrons in the 2s orbital. So we are going to get something like this. Two electrons in the 2s orbital. Okay, let me get it like this. There are two electrons in the 2s orbital, and there are two electrons in the 2p orbitals. So this is what 2p and this is what 2s orbital. So what is an orbital? An orbital is simply what? The region of what? Space. Where there's a what? Where there's a probability of what? 98, or where there's a 98% probability of finding an electron. A region of space where there's a 98% probability of finding an electron is known as orbital. So in organic chemistry, there are two electrons in the 2s orbital and there are two electrons in the 2p orbital. But there's a concept that is known as what? Excitation. Excitation is simply where an electron jumps from what? Its ground state. Know what it means to get excited. So that is what simply happens here. Now, what we are now in the types of hybridization. types of hybridization. That is what I'm trying to discuss now. Now, in the case of what? Excitation, one electron from the 2s orbital is going to jump to the 2p orbital, making the 2s orbital to have just one electron, making the 2s orbital to have just one electron, and the 2p orbital to have 3 electrons. To have what? So the 2s orbital is now having 1 electron, and the 2p orbital is now having 3 electrons. This is because 1 electron from the 2s orbital jumped to the 2p orbital, and this will give us a type of hybridization that is known as the SP3 hybridization. This gives us the SP3 hybridization. The SP3 hybridization, that's just it. 1 electron from the 2s orbital jump to the 2p orbital, making the 2s orbital to have 1 electron and the 2p orbital to have 3 electrons, thereby giving us the type of hybridization that is known as the SP3 hybridization. So that is just it. Let's talk about the SP2 hybridization, which is another type of hybridization. So the SP2 hybridization, for the SP3 hybridization, the SP3 hybridization occurs in what? Alkanes. Occurs in alkanes. Please take note. The SP3 hybridization occurs in alkanes. Then the SP2 hybridization, same thing that happens here also happens in the formation of the SP2 hybridization. But now get the concept. So we say in a normal carbon atom, there are 2 electrons in the 2s orbital. So we are also getting same thing like this. We are also going to get same thing like this. Please, I hope you can see it. This is the 2s. So we are getting same thing like this. We are getting same thing like this. That is for the 2p. But what is going to happen here that in the case of the excitation, say the SP2 hybrid orbital is formed when the 1 electron in the 2s orbital, when 1 electron here in the 2s orbital mix or blend with electrons in the 2p orbital, thereby leaving 1 electron unreactive. What that grammar simply means is that in the case of excitation, 1 electron from the 2s orbital is going to jump to the 2p orbital. Normally, we are not supposed to have 1 electron in the s orbital and 3 electrons in the 2p orbital. But the concept here, or what that changed, is that electron that is going to jump from the 2s orbital, that 1 electron that is jumping from the 2s orbital to the 2p orbital automatically becomes unreactive. And when it becomes unreactive, that means it has no place in the reaction. So at this particular time, or at this particular point in time, we will just be left with the SP2. We will be left with the SP2 hybrid. This is because the 1 electron that jumps or gets excited from the 2s orbital to the 2p orbital becomes unreactive and takes no place or effect in the reaction, making it redundant. So at this particular point in time, we are having the SP2 hybridization or SP2 hybrid. So that is how we get the SP2 hybridization. Same thing also happens to the formation of the SP hybridization. Now, take note that the SP2 hybridization is found in the alkenes, ALKENE. The SP2 hybridization is found in alkenes, while the SP3 hybridization is found in alkanes. That's for the SP3, while the SP2 is found in alkenes. So now let's head on to the last hybrid orbital that is known as the sp hybridization. The sp hybridization plays same role or takes same shapes from what we are just talking about. Now, in the sp hybridization is that normally note that we say we have in a normal carbon atom we have 2 electrons in the 2s orbital and 2 electrons in the 2p orbital. But what happened here is that one electron from the 2s orbital is going to get excited. So one electron from here is going to get excited, and one electron from the 2p orbital is going to get excited. Now these 2 electrons that becomes excited, one electron from the 2s orbital, one electron from the 2p orbital that gets excited becomes unreactive. In the case of their excitation, they become what? Reactive. If they become unreactive, note that we will just be left with one electron. We will just be left with one electron in the 2s, and we'll be left with one electron in the 2p. That means we are going to have something like this. That means we are going to have something like this. The S1 and the P1. Now writing it as S1 P1 is not that necessary, so we just simply write it as the SP hybridization. So that is how we get the SP hybridization, where we have the SP hybridization, which is mainly found in the alkynes and cycloalkynes. The alkynes and the cycloalkynes. The SP hybridization found in the alkynes. ALKYNES. So that is just it for the various types of hybridization. We have the SP hybridization. We have the SP2 hybridization, and we have the SP3 hybridization. So we are supposed to talk about the bonding in organic chemistry.